Okay, welcome, guys. Today I'll talk a little bit about chapter 5, which is uncertainty and consumer behavior. Just a little bit introduction. And then we're gonna have an in-class quiz. They are about chapter 3 and chapter 4, all right? First, let me remind you, okay, I uploaded detailed solutions here for this equation, right? In the exam, you have to show me your correct Lagrangian equation, Lagrangian function. Remember, objective function first, and then with constraint, all right? And then you solve it. First order condition, how you solve it? You look at this. Here you got, don't forget, okay, for first order conditions, you're gonna get 3 equations. And then you name it 1, 2, 3, right? And then you solve them. How you solve them? First, you set 1 equal 2, and then you're gonna get something. Let's see, y something. This is gonna be your equation 4. After this, you plug equation 4 into equation 3 because you haven't used equation 3. This is the logic about solving Lagrangian multiplier, okay? Basically, chapter 3, the same utility function. You need to know that x power half, y power half, which equals x power 0.5, y power 0.5, and also equal square root x times square root y, all right? So in the exam, when you see square root, don't forget convert it into x power half, okay? And let me talk a little bit about the new syllabus. I just uploaded to the Canvas, to the Mango, you can find it. Basically, this is our learning content, okay? 7 chapters, and for chapter 1, 2, 3, those are in the midterm exam. So now we finished topic 1, consumer behavior, topic 2, individual demand and market demand, right? So we only have uncertainty and consumer behavior. This is topic 3, but in chapter 5, all right? So 1, 2, 3 is for midterm. So of course, 3 to 7 is for final. It's about production, okay? It's about producer behavior. Next one, I want to remind you that about assessment. Sorry, it's so this is the exam date, okay? Can you get it in your Mango? As we agreed, right? It's 26 August, 3:30 to 6:30. Midterm exam covers topic 1, 2, 3, 3 chapters. For final, okay, we have 4 chapters, all right? And let me remind you, if you want to pass this course, which is easy, make sure you come to the class every day. This is 10%. And then you submit your homework with your effort. So basically, for those 2, you can get 30%, right? And then for the final and midterm, we're gonna have multiple choice question and also analytic question. For analytic question, of course, you need to know how to solve Lagrangian, okay? How to solve Lagrangian, how to draw the graph about chapter 4, okay? Remember, we have 3 types of goods: normal goods, inferior goods, and given good. How to draw them, how to get their demand, Hexen demand and Michelin demand, all right? So basically, the thing that I want to emphasize, right? So if you want to pass easy, you get about 50. But if you want to get A, show me your effort. Otherwise, you're gonna fail yourself. Okay, you're gonna fail yourself, not me. Clear about the midterm and final? If so, let me continue with chapter 5 a little bit, and then we're gonna have an in-class quiz. Okay, so here is chapter 5, uncertainty and consumer behavior. So far in chapter 3 and 4, we assumed something a little unrealistic. That you always know exactly what you are going to get. You know the price, you know the product, you know exactly how much satisfaction, which is utility. You'll get it. Life isn't like that, right? Today we start chapter 5, uncertainty and consumer behavior. This chapter answers a very real question. How do people make decisions when they don't know the outcome for sure? Think about the example. Should you buy travel insurance before flying to Bangkok? Should a Songdang vendor open a new store in a location where they don't know if it will be popular? Should you invest your savings in gold? Do you buy gold? Or in a bank account? Do you save it? Do you save? Or in a Bitcoin? Do you buy Bitcoin? In all these cases, okay, you don't know the result in advance, but you still have to decide now. That's what this chapter is about. We'll cover 3 things, okay? 5.1, we're going to describe risk. How do we even measure risk? How can we measure it? How can we quantify it? This is about 5.1. Seriously, we got 21 here. Only 16. Don't do that, okay? Don't send the QR code to your friends. I'm gonna have the in-class quiz later. Basically, I will know how many of you are here. Okay, next one, 5.2, preference towards risk. So this one is about some people love risk, some people hate it. Why? And how do we show that on a graph? Okay, preference towards risk. Next one, reducing risk. Can we protect ourselves from risk? Are you a risk loving? And we'll see how using tools like insurance, all right? So by the end of this chapter, you understand why people buy insurance. Do you buy insurance? Health insurance for sure. Why people gamble even when it's a bad bet on average. And why two people can look at the exact same risk situation and make completely different choices. Okay? So let's get started. This slide is just our roadmap, okay? 5 steps to understand risky decisions. First one, we need to put a number on risk, okay? That's why we see we need to quantify risk. You can't compare risky choice if you can't measure them. Next one, we will examine people's preference towards risk, right? Like I talked before, we look at how different people feel about risk. Some hate it, some don't. Next one, how can we lower risk? Okay, reduce or eliminate risk. In some situations, people must choose the amount of risk they wish to bear. That means sometimes you can't avoid risk completely. You just choose how much risk to accept. And sometimes the demand for good is driven partly or entirely by speculation. Remember, speculation demand. People buy the good because they think its price will rise. This is speculation demand. In the final sector of this chapter, we offer an overview of the flourishing field of behavioral economics. So at the end, we'll touch on behavioral economics. Real people don't always behave the way our clean models predict. No need to memorize this, okay? Just keep it in the back of your mind as our map for this chapter. Okay, let's start. To measure risk, we start with two building blocks, probability and expected value. Have you learned statistics? Statistics? Have you learned statistics? 脸了样 statistics. So you're gonna hear probability and expected value. What is probability? Probability likelihood that a given outcome will occur. Or just means how likely is something to happen. Simple as that. If I say there's a 50% chance of rain tomorrow, that's a probability. All right. Next one, expected value. And be careful, subjective probability is the perception that an outcome will occur because it depends on you. It depends on your judgment about the probability, right? So it's subjective, it's not objective. Okay, sometimes we know the real probability like with flipping a coin, which is 50-50, but sometimes we only have a feeling about that. So that's why we call it subjective, okay? Subjective. Next one, expected value. This is just a weighted average of all possible outcomes, weighted by how likely each one is, okay? Probability weighted average of the payoffs associated with all possible outcomes. I'm gonna show you how to calculate expected value later, right? And then what is payoff? Value associated with the possible outcome. Okay, this is payoff. So let me write it down. Probability equal how likely. Expected value equal weighted average outcome. These two ideas are the foundation of everything else in this chapter. And also when you learn statistics, when you learn econometrics, okay, we're going to talk about the probability and expected value for sure. Okay, this slide just formalizes what we did with the before. Okay, here's the share of stock. The expected value measures the central tendency, the payoff of or value that we would expect it on average. So you may think that expected means on average, okay, something on average. So here, let's see, the expected value equals the probability times the outcome plus another probability, which is failure, plus another outcome. Okay, so here the probability for success is 1/4 times 40 plus failure, which is 1 minus 1/4, right? Because 1/4 plus 3/4 equal 1. That's why you have 1/4 here and 3/4 here. Okay, you use your calculator, you're gonna get 25 shares. This is the expected value. $25 is not one of the two possible outcomes, okay? It's not 40, it's not 20. Expected value is just the center point, okay? Center point. The average, if this happened many times. So this is with two possible outcomes. The expected value is probability 1 times x1 plus probability 2 times x2. So in general, when there are n possible outcomes, let's see the expected value becomes, you just probability times the outcome, and then you sum them up, okay, until n, because we have n possible outcomes. Don't be scared by the notation. It's exactly what we did, okay? You just probability times the outcome and then sum them up. This is how we calculate expected value. Okay, so here is the key idea of this slide. Look at table 5.1. Two jobs, okay? Two jobs. Both have the same expected value, 1,500 baht. Okay, first job is commission based. What is commission? If you sell more, you get more. Job 2, fixed salary, okay? So let's see, how can we calculate? So for your preference, which job do you prefer? Job 1 or 2? Which one do you prefer? Job 1 with commission or job 2 with fixed salary? Let's see the outcome. So there are two outcomes, okay? If this outcome 1 happens, the probability is 0.5 for job 1. Okay, so how we calculate the expected value here? Basically, you use the probability 0.5 times 2,000 plus outcome 2. The probability is the half again, and then you times 1,000, you'll get 1,500, right? Can you use your mobile phone to calculate? Make sure is it true? Same logic. You use the probability times the outcome 1 plus probability 2 times the outcome 2. Can you help me check? Do they have the same expected value? Use your calculator. Job 1 commission based, 50% of 2,000, 50% of 1,000. Big swing, right? Big swing. For job 2, fixed salary, 99%, you're gonna get 1,510. And another 1%, you'll get 510. Okay, so this one almost always the same. Because 99%, you're gonna get 1,510 for sure. Okay. But here, the same average, but do those two jobs feel the same to you? Which one do you prefer? Which job? Which one do you prefer? Which one is risky? Can you tell me? Which one is risky? First one, yeah, first one. Which one you pick? Which one you will pick? If you are offered to those two jobs, which one you pick? Which one you pick? First one, then you are risk blocking. How about you? Which one? Same one. Okay, so here be careful. Even they have the same expected income, but it doesn't feel the same, right? It doesn't feel the same. So that means if we only judge two choices by the expected value, we cannot see, there's not so much information because right now they are the same. That's why we need deviation. Okay, we need deviation. What is deviation? Or we call it variability, okay? Variability. Deviation is the extent to which possible outcomes of an uncertain event differ. How can we calculate the deviation? Look at table 2, okay? So table 1, you got the expected value, which is 1,500. Next one, how we calculate? You just use the outcome minus expected value. Right, so here you use 2,000 minus 1,005. So you got positive 500. And then the same, you use 1,000 minus the expected value, you got negative 500. Okay, so this is the deviation. Same as job 2, you use outcome 1,510 minus 1,500. Okay, this is how we get the deviation. So for job 1, the deviation is positive 500 to negative 500, right? And job 2 deviates by positive 10 to negative 990. So which one is risky? The first one, right? Expected value alone, okay, from table 1, expected value alone doesn't tell us anything. Doesn't tell us everything. Two choices can have the same average outcome, but very different risk. That's why we need to measure variability too, okay? Variability here or deviation. If we get deviation, next one, we need to get the standard deviation. What is standard deviation? You square root of the deviation. What is standard deviation? Let's see the definition. Square root of the weighted average of the squares of the deviations of the payoffs associated with each outcome from their expected values. Remember from table 2, this is deviation, right? And the deviation is positive 500 to negative 500. If we just average them, they cancel become 0, okay? Because one is positive, one is negative, so they cancel out to 0. That's why we cannot average them. So instead, we square the deviation first. square. Okay, both square both deviations. 25K, right? Same here. And okay, so we square the deviation and then we take the square root. All right, so you see here. Something wrong here. Anyone tell me? This is 250,000, okay? You see here, the answer is here, table 3, okay? Deviation squared, 250K, 250K. So the weighted is 250K. And then we get how we get the standard deviation with square root, right? Square root. Which is 500, okay? Basically, in table 2, we square the deviation first because this removes the negative sign, right? We square them, so we remove the negative sign. Then we take the probability weighted average of those squared deviation. That's called variance. Okay, and then we take the square root to bring it back to normal units. That's the standard deviation. So here for job 1, we have the standard deviation, which is 500. For job 2, how can we calculate this one? It's the square root. I know that it's the square root of 9,900, right? But how can we get this one? Any idea? You need to use the probability here, okay? You need to use the probability here. Okay, so from table 1, you need to remember the probability. Job 1, half. Job 2, 0.99 and 0.01, okay? So here, the first one, see here, how we get 250,000. Okay, this is how. And for 9,900 is this, right? Okay, let's see. The average of the squared deviation under job 1 is given by, this is the probability, times the variance, times the deviation squared, times another half, and also the deviation squared, okay? So you got 250,000, okay? This is the weighted average deviation squared. Right, the same logic. You use 0.99 times 100 here because it's for job 2, right? And then you plus 0.01 times 980, 100. Okay, so you got 9,900 here. And then you square root. You take the square root and then you'll get 99.50, right? So the standard deviations of job 1 and job 2 are 500 and 99.50 respectively. That's why at the beginning we said that job 1 is risky, okay? Because more standard deviation, more variability. So the second job is much less risky than the first because less standard deviation, right? Because the standard deviation of the incomes is much lower. Remember, both jobs had the same expected income, but job 1's standard deviation is much bigger, meaning income swings a lot more. Job 2 is much more stable, okay? Let me write it down. So here, the rule is that bigger standard deviation, riskier. That's really all you need to remember, okay? The calculation steps, you can always look up, but understanding why standard deviation tells us about risk is the real point. Okay, so I'll finish it today. No, I mean for the lecture, not for the class. So let me mark it, it's 20. Okay, so I'm gonna stop sharing because I'm gonna use Kahoot. Please get your phone ready. We're gonna use Kahoot about chapter 3, consumer behavior, and chapter 4, individual and market demand. So I need to share the screen with my computer and have you reviewed chapter 3? Have you? Please scan. Let me see how many of you are actually here. 21. Let me give you some music. One. Okay, later we will start. You can come closer to see the choice clearly, all right? Come closer. Guitar. Guitar. Come on, scan the QR code. All right? I'll make it. More. We got 21 here. It's all about multiple choice question. Multiple choice question. $18, all of you. $20. Two more, right? Two more. I'll give the extra point to the top 3 students. Extra point. Top 1, you got 1 extra. Top 2, you get 0.8. And for the third, you get 0.5. Okay? $21, all of you joined. Okay, and a little souvenir, okay, for top 3. Okay, let me start. I don't know why there's no music. You have to choose 3, 2, 1. A list that specifies the exact quantities of one or more goods a consumer might purchase is best described as a market basket, which is a bundle, right? A budget line, indifference curve, and utility function. Boom is boom, boon, right? How to pronounce? Boon, okay. Which assumption? A person can always rank any 2 markets, prefer A to B, prefer P to A, or indifference. Completeness. Okay, I got the same number as my SMU mobile, 21. Transitive. Which conclusion follows? This is easy. A to B, B to C. That means she prefers A to C, right? Everyone choose the answer. You have to pick. You have to pick one. More is better than less means baskets with more of every good are always preferred, right? This is more than better. Because for normal goods, right, more is better. DeLorean. indifference curve. Indifference curve here. All baskets that give the consumers the same level of satisfaction, right? The same level of utility. Indifference curve is about satisfaction, utility. Pick one, pick one. Some of you didn't answer. Why can two indifference curves belonging to the same consumer never intersect? Who choose utility function are always linear. Indifference curve must be straight line. Who choose this? You need to watch the recording again, okay? What is marginal rate of substitution? You can come closer if you can say it. Right, the maximum amount of Y a consumer will give up to get one more unit of X, right? It's the slope. It's the slope of IC, right? So that means the change in Y over the change in X. I hope next time you saw this, I hope next time you see this question, you're gonna answer it correctly, okay? Diminishing marginal rate of substitution along the indifference curve implies the curve is convex to the original. Indifference curve is vertical. Vertical. Have you ever seen that I draw the vertical indifference curve? No, even not for perfect substitutes and perfect complements. Bob is willing to trade apple juice for exactly orange juice. Perfect substitutes, right? One for another one. Inferior good, given good. Left shoes, right shoes. Perfect complements. Normal, good. You should choose between ordinal and cardinal, okay? Not blue and yellow. Indirect utility function. I didn't talk about this. It's ordinal utility function, right? Ordinal, I mentioned that in microeconomics, we only know that we can rank, but we don't know the exact number. Who is DeLorean? Who? Okay. The budget constraint, what is the slope of the budget line? Px over Py. You rearrange it, right? X on the horizontal, that means Y on the vertical. You remove this part to the left side, to the right side, and then you divide it by Py, which is Px over Py. Income increases, okay, but price stays the same. What will happen to the budget line? Oh, okay. Right. So the income increases, the budget line will shift outward, right? But parallel, all right, to the original. Becomes steeper without shifting, rotates. We're gonna say rotates later. Okay, so here, price of Y falls, but price of X falls, price of Y remains the unchanged. So what will happen to the budget line? Something wrong here, something wrong here. Shift inward, parallel to the original. This is the income decreases, right? You should not choose this one because here is about price. Okay, so think about it. Price of Y, price of X. Here, the price of goods X falls. That means the consumer can buy more X, right? Before, this is the budget line. More X means the budget line is going to rotate outwards, right? Around the y-intercept, okay, rotate outwards, rotate, become flatter. Only 4 of you and 6 of you choose rotate outward around the x-intercept. This is price of y falls, right? Here is price of x falls. around the y-intercept, that means around this one, because price of y doesn't change, right? Okay, be careful. Interior optimal consumption bundle, which is the normal case. If we want to get the optimal, what is the condition? Right here. The optimal condition is MRS equals the price ratio, which means the budget line tangent to the indifference curve, right? Because MRS is the slope of the IC and the price ratio is the slope of the budget line. They have two tangent. Wait, this is about chapter 3. We'll go chapter 4. Who is the third? I couldn't see it. Jane and Delorean. Okay, so please, after the class, come and tell me your student ID. Now, let's see chapter 4. Okay, this is about chapter 4, all right? Individual and market demand. Several more, 18 here. Start, shall I start? Twenty, 20, one is missing. The curve that traces out utility maximizer combinations of two goods as the price of one good changes is called great price consumption curve. Why still budget line? Okay, this time consumers' income changes. Income consumption curve. This is in your homework. market demand curve. If the food is a normal good, okay, normal goods, if you have more income, you're gonna buy more of it. So the angle curve gonna increase, which is positive, and also as the income consumption curve, right? So both of them have positive slope. I think you guys are confused about normal good, given good, inferior good. When can we say which one is which? We only, so you, how we say that they are different goods? When your income changes. If your income increase, you buy more normal good. You buy less inferior good, or sometimes given good, okay? So we can only distinguish normal, inferior, and given by our income, okay? By our income. And when you see two goods, okay, they may substitute or complement, all right? Just be careful. So hamburger is what kind of good here? Before, it's a normal good, but when the income rises, the consumer buy less of it. Less of it. Yeah, inferior good, right? Margarine, what is margarine? If you know this word, you can do this question. What is margarine? Yes, human-made. Another kind of butter. So margarine is human-made from vegetable and oil, okay, not from the animal. So they are substitutes. Printer and printer ink. Independent. They are complements, right? The change in consumption of a good, that because a change in its relative price with the level of utility held constant. We call this one what kind of effect? Total income or substitute? You should not choose network effect, okay? So which one? Hold utility constant. That means it's substitution effect. Utility constant is for substitution, okay? So here the change in consumption of a good because the change in purchasing power caused by a price change is called What is price consumption effect? We don't have this one. We only have total effect, income effect, substitution effect. So here, change in purchasing power, which is income effect. Normal good. How do the substitution effect and the income effect interact to determine the total effect on quantity demanded? Remember the graph? Right, for normal good, okay, both substitution effect and income effect, they push quantity demanded in the same direction. A given good, what is a given good? Given good, right? When your income increases, you don't buy it or you buy less of it. So the negative income effect is larger than the substitution effect. That's why given good has an upward slope demand curve, okay? You should be able to draw the demand curve for given good. What is the difference between Hexen and Michelin demand? Exactly. Hexen holds utility constant and it only captures the substitution effect. All right. You need to draw Hexen and Michelin as well. Be able to draw it. What is the market demand? What is the quantity when price equal 4? Fast calculation, fast calculation. Two, one, two. You sum them up for the market demand, right? Q equal 30 minus 3P. And when P equal 4, you plug P equal 4, which is 18. Two more question. If the elasticity of a good is negative 0.4, which is inelastic, what happens to total consumer expenditure on that good if its price rises? Price and total expenditure move in the same direction when the good is inelastic. Okay, so here price rises, expenditure rises as well. Please review my lecture notes. Okay, consumer surplus is best defined as The difference between the willing to pay and the amount actually paid, right? The willing to pay minus the market price. Last question. Bandwagon effect, which is positive network externality. Given effect. Let's see. Now, gent? Is that gent? Claire, okay. Okay, so I finished my class. Thanks for coming. Please review, okay? Please review my teaching notes.